Can a system's capability to express a wider range of ideas and computations be its own downfall when it comes to solvability? This question underpins the fascinating relationship between expressiveness and decidability in the world of computer science, logic, and linguistics. Expressiveness, in its essence, refers to the breadth of ideas, computations, or problems a system can capture. Think of a programming language like Python, known for its high expressiveness, which allows developers to write programs for a vast array of tasks with relative ease. On the other hand, decidability is all about solvability. A problem is decidable if there's an algorithm that can always solve it. For instance, consider the finite automata from automata theory. They are less expressive than Python, but their questions, like, does this automaton accept a particular string, are always decidable. But here's where things get interesting. As a system becomes more expressive, it often leads to increased complexity, and with complexity comes the potential for undecidability. This is the expressiveness-decidability trade-off. A striking example of this trade-off is found in logic and theorem proving. First-order logic, which captures objects and their relationships, is less expressive than second-order logic, which also includes properties of properties. But while there are complete and sound algorithms for proving statements in first-order logic, second-order logic is undecidable, showing the trade-off in action. Programming languages also illustrate this trade-off. Turing-complete languages like Python or Java can express any computation that can be described algorithmically. However, determining properties like will this program ever stop is undecidable for these languages, a result famously proven by Alan Turing himself. The expressiveness-decidability trade-off even extends to natural languages like English or Spanish. Linguists grapple with this trade-off when developing computational models for natural language processing. Natural languages are highly expressive, capturing an infinite variety of ideas using finite means. But this expressiveness also results in ambiguity and context dependence, making certain aspects of language processing undecidable. A classic demonstration of this challenge is the liar's paradox. This statement is false. It's a simple English sentence, but trying to decide its truth value leads to a contradiction. So the trade-off between expressiveness and decidability is a fundamental aspect of computer science, logic, and linguistics. It's a delicate balance, a dance between the desire to capture more and the need to ensure solvability. As we continue to push the boundaries of what our systems can express, we must also navigate the complexities and potential pitfalls that come with increased expressiveness.